In a previous video, we've talked about how the sine of one angle and the cosine of its complement are going to be the same. We're going to extend on that today, and we're going to talk about that again some more. So as a refresher, we know that complementary angles add to 90 degrees. Okay, and also the acute right angles of a right triangle must be complementary, because if I have a right triangle, this is 90. All three angles add to 180. 180 minus the 90 I already know will leave me with 90 degrees for these two angles. Alright, so take a minute, find the sine and cosine of both angles A and angles B. Alright, so from angle A, I need to label, this should have had a right angle here, I apologize. Okay, it does say right triangle, and the longest side is 10, so I know that means that angle C must be my right angle. So the across from 90 is my hypotenuse, the side that touches the angle is the adjacent, and the side directly across from the angle is opposite. So with sine being opposite over hypotenuse, that's 6 over 10, which simplifies to 3 over 5. The cosine of A is adjacent over hypotenuse, so 8 over 10, or 4/5. Now I need to erase these and start over, this time from the perspective of angle B. 10 will still be my hypotenuse because it's still across from 90. 6 is my adjacent because it touches angle B, and the side directly across from B is my opposite. So sine of B will be opposite over hypotenuse, so 8 over 10, which is 4 over 5. Cosine of B is adjacent over hypotenuse. 6 over 10 simplifies to 3 over 5. So it says, what do you notice about the sine of A and the cosine of B? They are going to be exactly the same. They are equal. So what do you notice about the sine of B and the cosine of A? And they are also equal. Alright, so the trigonometric function of its complement angle is called a cofunction. So that means that sine and cosine are cofunctions of each other. Probably how the name came to be of sine and cosine, because cosine was a cofunction of sine and vice versa. Okay? Alright, so for example, if I have sine of 42 degrees and I want to write it in terms of cosine, all I have to do is switch sine to cosine and then do 90 minus 42, because the two angles must be complementary. So that gives me the cosine of 48 degrees. So what I would do is I would check in my calculator. Does sine of 42 equal cosine of 48? So I would type in sine of 42 and I get 0.6691. And then I type in cosine of 48 and I get 0.6691. So I know I did this correctly. You should not get any of these questions incorrect. You should be able to go back and check your work. So this time I have cosine of 36 and I wanted to write it in terms of, sine. Okay? So we change cosine to sine. We do 90 minus the given angle 36, so this should be sine of 54. So I check, is the cosine of 36 equal to the sine of 54? So cosine of 36 in my calculator is 0.8090, and sine of 54 is 0.8090. So we have exactly the same thing. We did this problem correctly. Alright, so what I'd like for you to do is take a minute and pause this video and give it a shot. Alright, now that you are unpausing the video, let's go ahead and take a minute and check our work. Remember, if it's sine, we want to write it in terms of cosine. We do 90 minus 28, So the answer here is cosine of 62 degrees. Cosine of 51 in terms of sine, 90 minus 51 is 39, so the sine of 39 degrees. Again, go back in your calculator and check, is cosine of 51 the same as sine of 39? If it is, you know that you did it correctly. Now occasionally we're going to have problems like this, where we need to know the value for x such that the sine is equal to the cosine. Okay? So, first things first, let's see what this hint is. We know that the two angle measures must add to 90 degrees because they are complementary, correct? So what I do is I take what's inside here and I add them together and equal to 90. So now I can combine like terms. 2x plus 3x, 5x. Negative 4 plus 9 is 5. So all I did from here to here is combine my like terms on the left-hand side. By subtracting 5 from both sides, I get that 5x equals 85. This is 5 times x, so I would divide by 5 to get x by itself. What you do to one side, you do to the other. So I get that x is equal to 17. Now the problem is, it doesn't say find x, it says find the two angle measures. So I'm going to go back up here and plug in 17 for x. So 2 times 17 minus 4 is 30 degrees. And 3 times 17 plus 9 is 60 degrees. So the two angles that I need here is the sine of 30 is equal to the cosine of 60. And I can verify because 30 plus 60 is 90. The two angles that I've found are complementary. Alright, here's a you try problem. Go ahead and take a minute and try this problem. Pause your video now. So what you should have done is set the problem up this way, where the two angles added together are 90 degrees. Oops. When I combine my like terms, I get 3x plus x is 4x. 2 plus 44 is 46 equals 90. Subtract 46, I get 4x equals 90 minus 46 is 44. Divide both sides by 4, x equals 11. This is not my answer, I need to plug it back in. So I take 3x plus 2, plug in 11, 33, 34, 35 degrees. So 33 plus 2 is 35. So that's my first answer. And then I take the second angle, x plus 44, so that's 11 plus 44 is 55 degrees. So I should have the sine of 35 is equal to the cosine of 55 degrees. Okay, 35 plus 55 adds to 90. I know that I did this correctly. Alright, that's it for complementary angles. Tomorrow we will begin solving right triangles using trig. See you later.